Hi everyone, my name is Ramesh. I am working as an associate professor in the Department of ECE, MLR Institute of Technology. Today we are going to discuss about analysis of CB amplifier using hybrid model. In the previous lectures we discussed about CE and CC amplifiers using hybrid model. So in this lecture what we will learn is what is the basic CB amplifier circuit and AC analysis of the amplifier circuit, AC equivalent circuit, H parameter model, how to draw H parameter model for a CB amplifier, and what are the current gain, input impedance, voltage gain and output admittance. So we'll find what is the current gain, input impedance, voltage gain and output admittance of a common base amplifier, and we'll see what is the application of the common base amplifier, whether it is acting like a voltage amplifier or current amplifier. We will conclude from the analysis part. So let us consider a CB amplifier analysis with NPN transistor. Consider NPN transistor is connected in common base configuration. Input is applied to the emitter terminal in common base configuration. Input is applied to emitter and output is taken across the collector terminal, and base will be acting as a common terminal for both input and output. Here we are applying input to the emitter terminal and output is taken across the collector terminal, and base is common for both input and output. So let us take the input capacitance is Ci and output is C0, and let us take the source voltage is Vs and the source internal resistance is Rs, and let us take this resistor which we are terminating at the output side is RL. Now this is the basic common base amplifier circuit by using NPN transistor. Now what is AC analysis of this particular circuit? We will be taking output across this. Now whether this signal is amplified or not, and what is the current gain, voltage gain, input impedance, and what is the output admittance or output impedance, that we have to find it out. So what is AC analysis? By considering the AC signal and nullifying the effect of DC sources, we can able to find out the AC conditions. So for that, what we have to do is first draw the actual circuit diagram and replace whatever the coupling and bypass capacitors by short circuit, because what is XC? Reactance of the capacitor is 1 by omega C, or it can be considered as 1 by 2 pi FC. So as frequency increases, what happens to the reactance? Reactance will decreases. As frequency increases, reactance decreases. That will be considered logically as a short circuit, and that's why we are nullifying the effect of coupling and bypass capacitors which are present in our circuitry, and we will nullify the effect of DC sources, and we will replace the transistor with its equivalent H parameter model. So H parameter model consisting of total 4 parameters, HI, HR, HF and H0. Input impedance, reverse voltage gain, forward current gain and output admittance are the parameters related to any transistor configuration. Now if you see the circuit, we have two coupling capacitors here. The coupling capacitors are Ci and C0. We will consider them as a short circuit. So the effect of these capacitors is considered as short circuit for AC analysis, and we will redraw the circuit, that is called as AC equivalent circuit. So what is the AC equivalent circuit? Same transistor as it is. Okay, and we will consider the Ci, that is input capacitance and output capacitance, with short circuit, and RL as it is. This will be short circuited, and this is the AC equivalent circuit. V0, this is output we are taking across the collector terminal, and input is applied to the emitter terminal. The input voltage is VEB, and input current is emitter current, and output current is collector current. Now let us consider this transistor with its equivalent H parameter model, so that we can able to analyze the parameters. So now we will draw the H parameter equivalent model for the common base amplifier for the given configuration, that is a common base configuration. The input is applied to the emitter terminal and output is taken across the collector terminal, and base is acting as a common terminal for both input and output. So the input parameters are HIB, that is input impedance, and next we have a dependent source. The dependent source will be depending on the output voltage. So it is HRB into What is the output voltage here? The output voltage is VCB, collector to base voltage, and input voltage is VEB, emitter to base voltage, and the input current is IE, emitter current, and output dependent source is current dependent current source. Now it is HFB into what is the input current? Input current is IE, so it is depending on the input current, and we have another parameter, that is H0B, that is output admittance. This is the internal circuit representation of the transistor in CB configuration, and whatever the external things which are there in the circuit we need to connect. So the external thing is Vs in series with Rs at the input side and RL at the output side. So Vs in series with Rs is connected between emitter and base. So we have to connect here the Rs source resistance along with source voltage at the input side, and at the output side it is terminated with RL, and across RL we are taking the output voltage V0. Now this input current is IE and output current is IC, output voltage is VCB. So the input variables are VEB, emitter base voltage, and emitter current. What are the output variables here? The output variables are VCB, collector base voltage, and collector current are called as output variables. So these are input variables, and output variables are collector base voltage and collector current. Now from this equivalent model we will find out what is the current gain, input impedance, voltage gain, and output admittance of a given common base configuration. So let us go for current gain. How can we define the current gain? The current gain is defined as the ratio of output current to the input current. So in the given circuit, so IC is the incoming current into the network, and IL is considered as the outgoing current and which is flowing through the load resistor. So how can we define the current gain? Current gain is defined as the ratio of load current to the input current. Here the output current is IL and input current is IE. So how can we define the current gain? Current gain is defined as the ratio of IL by IE, that is load current to the emitter current, or IL can be considered as minus IC. So the current gain can also be considered as minus IC by IE. So we derived the equations for the transistor amplifier circuit, current gain, voltage gain, input impedance, and output admittance. The same derivation part we can consider here for the analysis of common base configuration. So the current gain is considered as minus HFB divided by 1 plus H0B into RL. So this is the current gain expression for common base amplifier. And what are the parameters? Standard values of common base configuration is HIB, HFB, HRB, and H0B. What are the standard values? The standard value for input impedance is around 21.6 ohms, which is very low, and HFB is minus 0.98 HFB value, forward current gain, which is also very less, so that it cannot be acting as a current amplifier. And reverse voltage gain is around 2.9 into 10 to the power of minus 4, which is very less. And H0B is the output admittance, which is 0.49 microampere per volt. So what are the parameters here? The parameters HRB and H0B, these two can be neglected in simplified hybrid model to reduce the complexity. The parameters are reverse voltage gain and output admittance can be neglected because they are very small. In the analysis part, we can neglect these two parameters so that we can reduce the complexity of the circuit. Now coming to the next parameter, the next one is input impedance. Input impedance is defined as the ratio of input voltage to the input current. See the circuit, you will understand how to find out input impedance. It is the ratio of input voltage. What is the input voltage here? VEB, and input current is IE. Now we can write ZI is VEB divided by IE. It's a ratio of emitter voltage to the emitter current. Now according to the standard expression, how can we write this? ZI is HIB minus HFB HRB divided by 1 plus H0B into RL. Now the input impedance is depending on HIB. HIB value is very small, which is around 21.6 ohms. So the input impedance of the common base amplifier is very less compared with common emitter or common collector amplifiers. So this is related to the input impedance. Now the third one is voltage gain. Voltage gain is defined as the ratio of output voltage to the input voltage. See the H parameter equivalent circuit here. The output voltage is VCB and input voltage is emitter to base voltage. Now we can define it is the ratio of collector voltage to the emitter voltage, that is VCB by VEB. The voltage gain is defined as the ratio of output voltage to the input voltage. Now voltage gain standard expression is AIRL divided by ZI. So what is AI? AI already we derived. So it is minus HFB divided by 1 plus H0B into RL. What is ZI value? ZI is HIB minus HFB HRB divided by 1 plus H0B into RL. So this is the second equation. First we have to find what is the current gain, input impedance. Then we can easily find what is the voltage gain of common base configuration. So this will be acting as a voltage amplifier. This act as a voltage amplifier. Now fourth one, what is output admittance? Output admittance is defined as the ratio of output current to the output voltage seen into the network. If you see here, if you see this particular circuit, how can we define output admittance or output impedance, Z0 or Y0? So how can we define Y0 here is, it's a ratio of output current seen into the network. So it is IC divided by, what is the output voltage? Output voltage is VCB by making Vs is equal to 0. So at Vs is equal to 0, the ratio of collector current to the collector base voltage is called as output admittance. Here if you see, Y0 can be defined as ratio of collector current to the collector base voltage by considering the source as 0, source voltage as 0. The standard expression for the output admittance is H0B minus HFB HRB divided by RS plus HIE. This is the standard expression for the output admittance. It is H0B minus HFB HRB divided by RS plus HIB. So H0B, as we know, H0B value is very small, which is around H0B values around 0.49 microampere per volt, which is very less, so that we can neglect output admittance. If you neglect output admittance, what is Z0? Z0 is output impedance, which is the reciprocal of Y0. So 1 by Y0 will be the output impedance. So if we output admittance is very less, means output impedance is very high in case of common base amplifier. So what are the characteristics of this common base amplifier? So the main characteristics of this common base amplifier is the input impedance is very low, output impedance is very high, the voltage gain is high, and the current gain is approximately unity, because it is minus HFB divided by 1 plus H0B into RL. So minus HFB value is around 0.98, so which is very small. So in that case, the current gain is almost unity, and voltage gain is high, input impedance is low, and output impedance is very high. Therefore, in a practical applications, common base amplifier will act as a voltage amplifier. It cannot be used as a current amplifier. So in this session, we discussed about the common base amplifier using H parameter model. Up to now, we completed CE, CB and CC amplifiers using exact hybrid model. Now next session we will discuss about the simplified hybrid model of CE, CB and CC amplifiers. We will neglect two parameters. What are the two parameters which we can neglect here is HRB, reverse voltage gain, and H0B, output admittance, can be neglected in practical analysis of the circuits, so that complexity can be reduced if you go for multi-stage amplifiers. So in next session we will discuss about CE, CB and CC amplifiers using simplified hybrid model. Thank you for watching the video.